designing a low-cost ventilator, and in order to decide how the motor will control the breathing function, we need to come up with some models of what the breathing function look like. And so these are some models I've made here and graphed out. We've got a bunch of different lines showing up here. I can hide some of them to make it simpler, but the dotted lines here are the flow loop diagram. The dashed lines are the flow rate versus time, and then the solid lines are the volume versus time. And then all of the blue is during the inhalation, and the red is during the exhalation. So I'm going to hide the flow rates so we can just take a look at this flow loop, which corresponds to this volume function here. Flow loops are pretty common in spirometry, the measurement of breathing. So this will automatically sort of map my breathing flow loop to my function versus time. And that's what some of these equations over here are doing. And then I have some variables I can play with. So this B value will change the slope here on my flow loop diagram. And you can see the volume of the breath. You can see this kind of changes how quickly the exhale happens. And then the time right now for the inhalation is 2 seconds, but you can make that shorter or longer, and you can see how that also changes the flow loop. Same thing, the time with the exhalation, it goes shorter or longer. And then this is the tidal volume, which is essentially the max volume of the breath, and it's pretty common for half a liter. So I can put any of these values where I think would be natural for breathing, and then I'll just take these values, plug them into my equation, and I'll get a model for how the flow rates and the position of the motor should be in order to get my flow loop the way I want it. So the flow loop relates to the volume versus time curve in a few ways. The way I'm plotting it, it's a parametric function where I'm plotting the volume versus time against the flow rate versus time. And the flow rate is just the derivative of the volume. And so if I put my flow rates back on, you can see this is like a cosine function, and its derivative would just be the sine. This is an exponential, and we get an exponential derivative like we'd expect. So those are our flow rates. And so the flow loop, if we think about what the axes are on the flow loop, we would have volume on this axis right here, and volume versus time on this axis. And so it's a little confusing to think about, at least I find it a little non-intuitive compared to just the volume versus time. It's kind of simple. You're just seeing, how much air is in the lungs at what time, where this, the time component is kind of hidden in the graph. So I have to take some derivatives in order to convert my volume versus time graph into my flow loop right here. So eventually we'll need to program the stepper motor to precisely control our flow rates and volumes and everything, and this model will help us to get that.